Life hasn't disappeared from the Earth yet, because a few species have managed to survive the cataclysms that have marked each transition from one era to another. Animals, plants, and microorganisms have managed to hibernate during the years following the impact of a large meteorite, or have overcome radiation, droughts, or extraordinary atmospheric changes. The biggest mass extinction killed off 95% of the beings that lived on the planet 250 million years ago. The ones that survived must have known the secret of how to die just a little bit, sleeping close to death. Those are the main variables that turn on or turn off the internal biological clocks of every living being. What leads them to wake up from hibernation, to mate in the spring, or to go to sleep in winter, or when faced with a drought, are climatic parameters that each species, at any given time, interprets as favorable or unacceptable. The environmental conditions determine whether they can live or not. Organs, senses, and cells act in each animal, preparing it to become active or inactive. When facing a big diapause, a prolonged period of suspended activity that can last years, their bodies have to be very careful and follow every step dictated by their hormones. Obedience to the biochemistry involved is the first requirement in order to be able to wake up again someday undamaged from a sleep that looks like death and that comes quite close to it. They often come in contact. In the case of animals, the respiration, heart rate, blood circulation, and brain activity slow down, and sometimes almost stop. Death is what that is when it happens forevermore, when the ability to revive is lost. Is there a time limit to staying in suspended animation? How long can a living being survive while in a deep sleep? There are many degrees, many levels of lethargy. There's a story about a snail that woke up after sleeping for 200 years in a display case in the Natural History Museum in London. The security guard who discovered it offered it some lettuce from his sandwich, and the snail ate it. Now, we don't know if this is a legend about snails or about the dedication of British guards to their jobs, but science says that a snail can sleep for 1 season. Perhaps some species can sleep for 2 if the environmental conditions are unfavorable. But 200 years? That seems impossible. Is it? Each year, this species of snail spends a maximum of 3 months in total torpor. Beyond that period of time, if the environmental conditions don't allow it to wake up, the death rate of the sluggish snails grows exponentially with each passing day. These animals need humidity and mild temperatures. They don't like direct sunlight either, because their skin is extremely fine and sensitive to ultraviolet light. That's why they're active at night. That's also why, when the cold weather arrives or the heat is unbearable, they disconnect for a week or two, and then wake up again. And they can go on living this way, intermittently, putting themselves on hold and then connecting themselves again whenever their favorite weather conditions return. Life on Earth is conditioned by environmental fluctuations. The temperature, humidity, and light are affected by cyclical processes. In most cases, we're talking about mild and progressive variations like the changing of the seasons. But sometimes life has to face catastrophic events, like the radiation from supernovas, the impacts of large meteorites, or alterations in the Earth's magnetic axis. These cataclysms change the environment radically in a very short period of time. Lethargy is a crucial response for survival. On a spherical planet, as we move away from the equator, the rays of light from the star that heats the planet's surface hit the ground at a greater angle. That is, in a milder way as we approach the poles. And since our planet's axis is also a little tilted, each half of the Earth receives the sunlight with alternating strength. Which is to say that when it's summer in the north, it's winter in the south. The toughest conditions force many living beings to sleep several months of the year. The cold paralyzes the growth of plants and insects. And without the most important elements in the trophic network, finding food becomes an almost impossible task. Birds still haven't learned how to hibernate, as do many of their prey, which, if they're well hidden while they sleep, will survive to see the next season. Although hibernation isn't entirely free of risk either. Biologically, it may seem fairly simple for an arthropod to turn itself off and on again. Its brain, nervous system, and digestive tract are very basic. Nonetheless, starting up or stopping an organ or a whole organism requires a very precise synchronization of molecular and metabolic mechanisms. Even electricity is needed. A deep diapause has a lot in common with the absence of life. all bodily functions decrease, and the ability to synthesize energy is minimized. That's why many animals never manage to wake up again from that deep sleep. Although they hide inside thick old tree trunks, the wood doesn't always provide enough insulation. And the weakest ones, the worst fed, cross the frontier and are lost forever. Suspended animation involves risks, but evolutionarily, it's been worth it to take on those risks. For many species, staying active at the wrong time of year would be even more dangerous. Without food, exposed to such adverse weather conditions, they wouldn't be able to survive if they were awake. Hibernation is an indispensable skill to be able to live in certain ecosystems. And it's not just an adaptation of the most basic beings. Vertebrate animals are also able to become dormant and minimize their bodily functions. Fish eat according to the temperature of the water. The lower their body temperature, the less they need to eat. So each species of fish becomes lethargic below a certain temperature. And even though they need to get their oxygen from the air, when certain turtles go into their winter trance, they reduce their metabolic activity so much that they're not forced to rise to the surface and can absorb enough oxygen through their skin or their supervascularized cloaca. Dormice are legendary sleepyheads. During their period of normal activity, in spring and summer, and a large part of the autumn, they sleep during the day and only leave their dens for a few hours each night. That explains part of their fame, but in addition, when the real cold weather arrives, the dormouse curls up to sleep in a deep hole in a tree trunk that it is also filled with plant material to bundle itself up in. In the high mountains, a bear in its den reduces its energy consumption by 50%, while a dormouse cuts it by more than 70%. Its heart beats once an hour, and it hardly breathes. Although on the milder days during the less taxing periods of its winter hibernation, a dormouse can wake itself up and eat something from its pantry, which it can digest in just a few hours. With that and the fat that it accumulated in the fall, it's certain to survive another year. The most extreme form of hibernation is freezing. No animal can survive indefinitely with its tissues and cellular liquids frozen. But some reptiles, specifically some turtle species and some snakes, can survive while partially frozen, at least for 2 or 3 days. That may not seem like a very long time, But it can mark the difference between success and failure when winter shows up with low temperatures that are even lower than usual. The Paris's frog can withstand being frozen for an even longer time. As soon as its body perceives a sharp drop in temperature, it begins to synthesize glucose, which is a good antifreeze. Its body also has other protective substances that slow down the freezing process, and still others that reduce the expansion of its cells when the volume of the water inside them grows as it turns into ice. Thanks to chemistry, the animal prevents its tissues from being torn apart and manages to survive for a longer period of time in some exceptionally tough conditions for its ecosystem. Being able to withstand the 5 coldest winter days is all it needed to colonize a lake a little higher up on the mountain, and to reach the spring and wake up with the spring thaw. The amphibians are an ancient lineage of vertebrates. Only fish are older. But living out of water is much more difficult, especially because of the changes in temperature, which you have to adapt to if you want to conquer new territories. Seawater varies some 30 degrees Celsius from the Arctic Ocean to the Red Sea. But out of water, the planet's temperatures vary more than 100 degrees Celsius. And yet amphibians have been able to colonize almost every ecosystem, even the most difficult ones, where there is hardly any water at all for most of the year, which has led amphibians to swap the hibernation strategy for estivation. Amphibian skin, even that of toads, which is thicker than that of frogs, can't withstand dehydration, nor prolonged exposure to direct sunlight. To endure that, amphibians would have to have scales, like reptiles. But instead of that, they bury themselves, looking under a few centimeters of mud for the humidity that will keep them cool and hydrated until the sun relents a bit. Estivation tends to last only a few weeks or even days, just during the driest moments of the summer. Although sometimes droughts can go on for years. The amphibian lineage descends from the fish, and no doubt fishes were forced to conquer the land when droughts began to turn their liquid medium into an unbreathable and unswimmable sludge. Some, like the West African lungfish, have developed actual lungs. What's more, this species has learned how to sleep for months, even years, while buried in mud. When a lungfish is trapped without water on the bottom of what used to be its swamp, it starts to change from using its gills to breathe to using its lungs. It's a difficult moment, and no doubt a source of great anxiety for the fish. At the same time, it has to look for salvation by burying itself in the mud before the soil hardens completely. It has to undertake these two tasks immediately and simultaneously. It digs as deep as it can, trying to get far down so as to avoid dehydration, because it doesn't know whether it will have to wait a year or 10 years before conditions return to normal on the surface. It's a mission that pushes it to the brink of its survival chances. But it's done it before. Its body gradually grows accustomed, and when it reaches the point where it feels safe, it stops to rest. Over the next few hours, it will gradually secrete a mucous membrane that will wrap it up and will dry out on the outside, forming a film that will protect it from dehydration. Its metabolism will slow down, as will its energy consumption and its respiratory rate. It even seems to have died. Fish like this have been found forming part of mud huts that had been built more than a decade before, and which came to life again when the hut fell apart during a rainstorm. Thanks to their feathers, birds have few problems with the temperature. But the little hummingbirds have an extremely high metabolism. To hang in the air like that and be able to drink from each flower, they have to stabilize themselves by beating their wings at incredibly high speed, which involves burning up an enormous amount of energy. They have to eat constantly, but they need light to fly because at night they wouldn't be able to aim their beaks at the hearts of the flowers. Plus, they would crash into the branches, and at the speed at which they move their wings, any collision would be deadly. How can they avoid starving to death if they have to spend the whole night fasting? The solution is a kind of deep sleep in which their daytime body temperature drops from 40 degrees Celsius to less than 28. They fall into a stupor, entering a kind of sleep similar to hibernation, but that only lasts as long as it's nighttime. Bats also have a very high metabolism. But unlike hummingbirds, they sleep all day. Well, and almost all night. Most bat species, especially the insect-eating species, only come out to fly about 4 hours a day. They start now, right after sunset. It's not because they're afraid of the light, nor because rays of sunlight disintegrate them like vampires. It's because twilight is the best time for them to go hunting without being attacked themselves. Bats are the animals that sleep the most throughout the world. They don't just hang upside down about 20 hours a day, but the species that live in latitudes where the winter is cold also have to sleep during the months when the insects aren't around. If you add up all those hours of snoozing, bats in temperate zones are only active during 20 or 25% of their lives. When there is intense cold, bats reduce their bodily activity to avoid using up their energy reserves. That keeps them from dying of starvation, but it also makes them vulnerable. If a predator found them in that state of lethargy, they'd be doomed. Their muscles can't reactivate that easily, so they wouldn't be able to fly away and escape. Birds are descendants of the dinosaurs, and the best adapted of them became today's most efficient predators. Birds don't hibernate, but they have specialized in looking for food in the toughest of times. There aren't any fruits now, nor seeds, and the insects are either hidden in the form of eggs or larvae, or they've died. And this bat chose the wrong place to sleep. This was a brutal banquet. The cold makes one tremendously hungry. Only the wings are left. The magpie has managed to pack away reserves for several days. Although not all insects disappear when the temperature drops. The pine processionary is an exceptional animal. And also its way of sleeping, or various ways of sleeping. The larvae of this species of moth are able to survive the rigors of winter without having to enter a process of deep lethargy. Their sleeping bags, made of countless layers of dense threads of very fine silk, are high-tech constructions that were designed to protect them from predators, and above all, from the cold. Inside, there's not only a numerous colony of caterpillars squirming around and keeping each other warm, but the community lives surrounded by their molted skins and their excrements, which both provide insulation and generate a little more heat when they decompose. So at night, when the hungry birds of winter can't see them, they calmly come out to eat the needles of the pine trees they live on. By day, these caterpillars would be an ideal meal when the rest of the insects are scarce. However, this isn't the most surprising tactic that this species has developed. During the winter, they're even able to stay active at night, protecting themselves from the cold as very few are able to. But when spring arrives, like the majority of moth larvae, it's time for them to undergo metamorphosis. And that's when it's very easy to understand how they got the name pine processionary. The line in which they walk one after another as they look for the best place to bury themselves is a continuous line that is rarely broken, since each larva follows the thread of silk left by the one in front of it, and that one follows the one in front of it, and so on, right up to the lead caterpillar. This safety line that they make as they march along is their safe conduct to find the place where, while they were sleeping in their cocoons together like the siblings that they are, they saved the meteorological signs that will wake the colony up at the right time. But not all of them will emerge as moths at the same time. They will do so in successive waves, over a period of 3 straight years. That's how they avoid all of them dying if they were born in a year of a drought, or if a predator discovers them at that precise moment. With the intention of preventing the total devastation of the colony, after the first season of sleep underground, only 60% of these individuals will wake up. The second year, another 35% will become moths, while the remaining 5% will come out into the light the third year. Many insects have learned how to live intermittently, avoiding the environmental conditions in which they face the greatest risks. They do this while in the larval stage, or in diapause in the embryonic state in eggs or in their cocoons. They work like real time machines. These primitive beings have learned how to live at intervals. That way they can keep safe for decades or more. They've learned to wait in the same way that we think their ancestors did, the most primitive life forms, when life had to confront huge cataclysms. Several more mass extinctions have occurred since the first in the Cambrian period. The most horrific one, the Permian extinction, occurred 250 million years ago and is informally called the Great Dying, since 95% of the planet's species died off. By comparison, the extinction during the era of the dinosaurs was much more moderate and the last of the mass extinctions. Although there are those who assert that we have now begun a new mass extinction brought about by human behavior. How do living beings confront what we know as an extinction event? What are the 5 or 10% of the species that survive the glacial periods, and what do they do? Or the ones that manage not to die out before the eruptions of supervolcanoes, the impacts of meteorites, or supernovas that explode too close to Earth? Perhaps only those that know how to sleep deeply manage to survive these events. Maybe it's thanks to their siestas that we're still here. This is one of those very rare species that most certainly would be able to survive a mass extinction. The Artemia salina is a primitive and simple life form. This crustacean is a species of brine shrimp, a relative of the true shrimp. Its ability to hatch and reproduce in a very short period of time is extraordinary. The Artemia is a successful animal that has colonized the whole world. Artemias are the multicellular beings that take the least time to complete their entire biological cycle. From the moment they are born to when they produce their own descendants, barely 15 days go by. The colonies are constantly in the reproductive process. It's always possible to see the males trying to fertilize the females' eggs, and the females depositing them, covering the muddy bottom with their chances for survival. The Artemia salina can live in all kinds of water, but it prefers brackish water. Even water that is too salty for the rest of life is for them an acceptable environment where they find hardly any competition or predators. Only flamingos have learned to live in the same setting, and so the birds feed on them whenever they can find them. But the Artemia's reproductive rate is so high that the birds and crustaceans stay in balance. Nonetheless, the Artemia salina's true specialization, allowing it to go where nobody else can, is its ability to overcome the most hostile environmental conditions. It has adapted to truly extreme ecosystems. It can withstand being frozen and the highest of temperatures and exposure to ultraviolet sunlight. We also know that it has survived the longest known droughts. In an embryonic state inside the egg, it can avoid becoming dehydrated and survive for decades. In some desert ecosystems where Artemias are found today, we know that they have gone through very long periods, even hundreds of years, with no rain. Some speculate that even though it might be a very small percentage, some of these eggs only as wide as a human hair could survive for centuries buried alive in the dust. Perhaps sleeping for 1,000 years. The diapause process through which these eggs stay alive in suspended animation is called anhydrobiosis. All metabolic processes come to a halt as it waits for rain almost indefinitely, as if it were dead. Clouds bearing rain finally arrive. The pace of the artemia's resurrection is dizzying. The surviving individuals gather together to eat and reproduce again, just in case they suddenly have to go back to sleep. The Artemia salina might be a good model to follow to survive a mass extinction. Plants also know how to sleep. We have evidence that they can sleep for thousands and thousands of years. In plants that shed their leaves, it's quite obvious when they're dozing. The green chlorophyll that captured the sun's energy in the summer ceases to be necessary in the leaves and is reabsorbed. Then the other pigments that were hidden in each leaf become visible for a few days. Reds and yellows are the colors of the substances that the tree produces to protect itself from an excess of solar radiation or from herbivores. But when capturing the sunlight is no longer worthwhile for trees like beeches, they collect all the nutrients they can from each leaf and they isolate it completely from the branch holding it. They even stop providing it with the slightest bit of water. And finally, the air tosses it to the ground. The soft bed that the leaves form down below also help the forest floor to withstand the cold and to renew itself for the next life cycle. In those latitudes where the seasons are as hard as ice, the sap stops flowing in the trees during the cold months. The tree trunks and branches stop growing completely, and any apparent sign of life in them disappears. Beyond even the strictest hibernation in animals, life in plants comes to a complete standstill, above all to avoid freezing to death. Although plants have an even more extreme form of sleep. What is the longest sleep ever recorded? That's a question that is directly linked to the definition of life. Because some forms of sleep are hard to distinguish from death. Are these grains of barley alive? Some, yes, but others have dried out and are dead. They're 5,000 years old. They came from an ancient Egyptian tomb. Can we distinguish the seeds that can germinate from those that can't? Inside each grain, certain molecules have been waiting for a very long time for physical signs of the right light, temperature, and especially humidity to set in motion the chains that replicate DNA. When these ancient seeds have been planted in soil, some of them have taken root and given rise to a new plant. Maybe only a very small percentage can manage to wait that long, but what a great awakening. The mechanism of suspended animation while waiting for the right conditions for life is fascinating. Life's patience and endurance is taken to the limit in the sleep of seeds. Apparently inert embryos, where some form of life is waiting for that germinal spark. Life is very obstinate. It endures beyond any difficulty, beyond any species. Even if the whole planet died, we now think that life, in some primal form, could be traveling through the universe on asteroids or in the ice of comets that were parts of other worlds. So perhaps the universe is overrun with latent life, sleeping on the edge of death, waiting to reach places where it can wake up.